Hello students, welcome to the first lecture on gravitation. We have seen that whenever we throw something upward, let's say from here, whenever we throw something upward, it falls down to ground again, right? Every time we throw something upward, it falls down to the ground. Why is it like that? Why everything has to fall down? Just like the rain falls down, and then the fruits from the trees fall down. Okay, now think about, you are standing here, you are throwing something upward, it goes downwards. Downwards means towards the earth, right? Now we know that the earth is a spherical shaped body, right? Earth is a sphere. So if you are throwing down upward from somewhere here, at the same time, if at the other side of the earth another person throws another body this direction, it again comes down. Now from these two positions, position A and B, it is clear that the upward and downward is a relative term, right? If from this point you can say that if you are throwing upward in this direction and the body falls down to the earth, but at the point B it throwing in the opposite direction and it comes down to the ground again, although it is in the opposite direction. So in these two cases we can say that instead of upward and downwards, we can say that if we throw something away from the earth, the body comes back to the earth, right? Why is it like that? It can happen, it can also happen somewhere here or here or here, everywhere on the earth, right? So it can only happen if when the body is being attracted by the earth, and because it is attracted towards the surface, we can conclude that it is actually attracted towards the center of the earth, right? That means the earth is attracting each and every particle with some mass towards its center. This force of attraction is called the gravity. We call it gravity, right? So gravity is a force of attraction with which the earth attracts another mass towards its center of mass. That's called the gravity, or in more common word we can also call it weight. It's the most common word that we use in our daily everyday life, weight of the body, because we can say that everything falls because of its weight. So that's actually gravity. Alright. Now not just the earth, actually any two bodies with some masses on the universe attract each other towards their center of masses. Let's say a body with mass m1, another body is with mass m2, okay? Then these two bodies are also attracting each other with some force of attraction F, okay? So this phenomena, this is a natural phenomenon. It's not like that somebody is sitting here and attracting the body, right, or pulling the other body. It's a natural phenomena in which the body is attracting the other mass. This natural phenomena is called the gravitation. This is called the gravitation. That means gravitation is a natural phenomenon in which a mass is attracting another mass towards its center of mass. If one of the masses is earth, then this gravitational pull or F is called the gravity, alright, or weight. If one of the masses is earth or the world, then it is the weight or gravity, okay? Now this gravitational pull F or attraction, gravitational attraction F, the force of attraction F, depends on the things that we will be talking about. What are the things it may depend on? Of course, let's say if we keep m2 constant and if we keep on increasing the mass of the first body m1 slowly, what will happen to the force? The force will also increase because the mass is increasing, it is getting bigger and bigger and bigger, right? So this, we can say this gravitational pull is directly proportional to the one of the masses m1, right? Alright. Similarly, if we keep m1 constant and if we keep on increasing m2 slowly, then this force of attraction will also increase this time. Alright. That means it is also directly proportional to the second mass. Okay. Now if the distance between these two bodies is, let's say, d, between the center of masses is T. Now what happens to this attractive force if the two bodies are slowly brought apart from each other? What will happen to the force? If they go away from each other slowly, the force of attraction will also decrease slowly. That's the natural observation says, right? So F is directly proportional to the inversely proportional to the distance between the bodies, but not not just D inversely proportional to the D, but it is inversely proportional to the square of the distance between the two bodies. Alright, so these three things are actually put together by Sir Isaac Newton, and they are termed as the universal laws of gravitation. Okay, universal laws of gravitation. Universal laws of gravitation. Why is it called universal? What is the meaning of the word universal? Universal means this law is valid for anywhere on this universe, be it on the surface of the earth or on the surface of the moon or on the surface of the sun. Wherever you go, this law is valid everywhere. That's why it is called the universal laws. Okay, now these things put together, we can say that the force of attraction, number one, the force of attraction between two bodies or two masses is directly proportional to the product of the two masses, M2, product of the two masses of the bodies. And then secondly, this force of attraction is inversely proportional to the square of the distance between them. And then thirdly, we can say that this force of attraction acts along the line joining the two center of masses. If we put a dot here, then this force of, this is a vector, right? Force is a vector, so it must act along this line which joins two center of masses of the bodies. Okay, so it is acting along the line joining two center of masses. Okay, and these three rules are combined together and called the universal laws of gravitation by Sir Isaac Newton. Alright, now if we combine them together, we can write that F is directly proportional to the masses, product of the masses, and inversely proportional to the square of the distance. So something like this. If we make an equation out of this law, then we have to put a constant of proportionality, which is in this case G, capital G. In this case it is written as capital G, which is the constant of proportionality in this case. Okay, so G m1 m2 by r square or d square. Okay, where F is the force, G is the constant of proportionality, m1 is the mass of the first body, m2 is the mass of the second body, d is the distance between the two masses. Alright, so this is the equation for the universal law of gravitation. Alright, now this G is called this constant of proportionality is called actually the universal gravitational constant, gravitational constant, and its value is very small, which is measured to be 6.673 into 10 to the power minus 11 SI unit. Now what is the unit of this? We can find from this equation. The equation says that F equals to G m, or let's say m1 m2 by d square. So we can from there write that G equals to we take the d square to the left hand side, so it becomes F d square divided by m1 and m2 to the denominator in the left hand side, so it becomes m1 m2. Right, now F is the force which is Newton in SI, d is the distance which is meter, in this case square, divided by m1 is the mass of the body, whose unit in SI is kg, so in this case kg into kg. That means the SI unit of G becomes Newton meter square per kg square. So that's the SI unit of G. That means the value of G becomes 6.673 into 10 to the power minus 11 Newton meter square per kg square. Okay, that's the unit of G. Alright. Okay, so that's the universal law of gravitation, and this is the universal gravitational constant. Okay, so this is the force by which every body with some mass attracts another object with some mass. If one of the masses is earth, then that force of attraction is called the gravity or the weight. Okay, now when something falls down, let's say if something is dropped from some height, right, everything that is free to move everything that is dropped from some height and free to move falls down, right, towards the surface of the earth. Alright, why is it falling down? Because of its weight. Because of its weight, right? Now because there is weight is a force, because there is a force, there must be an acceleration, right? Because force equals to mass into acceleration, we know that. So because from the Newton's second law, we have studied that before. That means wherever there is force, there must be some acceleration. So when a body is falling without with the gravitational force, what is the acceleration of the body? We will find that here. Okay, when something is falling down only because of its gravitational pull or its weight or its gravity, whatever you can call it, when something is falling down towards the center of the earth only because of its weight, no other external force is there. Remember that. Such a motion of the body is called the free fall. We have talked about that before in my previous lectures, if you remember one of the lectures. Okay, so this is the free fall. Free fall is a motion of a body that is falling from a height towards the center of the earth only because of its weight, no other external force is there. All right. Okay, so what is the acceleration of the freely falling body? First of all, you have to know the force. So when let's say the body is on the surface of the earth, let's say, first of all, okay, or at some height h. Okay, now what is the force of attraction on the body due to the earth? Must be G, mass of the earth, into the mass of the body divided by the radius of the earth square. Okay, or we can more precisely we can say radius of the earth plus h square whole square, right? Okay, so we can draw it more clearly, something like this. If this is the earth, this is the radius of the earth, and the body is falling from some height h. Mass of the body is m, mass of earth is capital M, let's say. Okay, alright. Now remember that r is the radius of the earth is much greater than the small height of a building. Let's say that's very small, because the height of a building might be some few, let's say 20 meters, 30 meters, even 100 meters, but the radius of earth is given as r equals to 6.4 into 10 to the power 6 meter. Remember that, which is a huge number compared to the height of some building or some tree. Okay, so we can ignore this h and we can simply write that G m by r square. Alright, the force of attraction on a freely falling body from some small height. Alright, okay, the mass of the earth is given as m equals to 6 into 10 to the power 24 kg in SI unit. Okay, this is the mass of the earth, okay. So this force becomes F equals to, we know that G m by r square, that's the force on the gravitational pull on any body, equals to, now from the Newton's second law we know that it's given as for F equals to ma, right? So that means the mass of the body into A. Let's say the A is the acceleration with which the body is falling. Alright, so it becomes F equals to ma, which is gmm by r square. Therefore, it gives as A, which is the acceleration, equals to what? Gm by r square, equals to, what is the value of G here? We know that G is 6.7 into approximately, of course, 10 to the power minus 11, which is a very small number, into the mass of the earth, which is 6 into 10 to the power 24 kg, divided by r square. R is the radius of the earth, which is 6.4 into 10 to the power 6 meter square, which is whole square. Okay, this is meter per second square. That's the acceleration of the body with which the body is falling, or acceleration of a freely falling body, which is approximately, if you calculate these numbers, just find out a calculator and then calculate them, and you will find that this is actually given as 9.8 meter per second square. Okay, so the acceleration by which and a freely falling body is falling towards the earth center is given as A equals to 9.8 meter per second square. This is called the acceleration due to gravity. This is called the acceleration due to gravity, and in general it is written as small g. This is denoted as small g. So small g is the acceleration due to gravity, acceleration due to gravity, and it is given as 9.8 meter per second square or 980 centimeter per second square in CGS. Alright, so that's how you find the acceleration due to gravity. That means every particle with some mass falling towards the center of the earth or freely falling with some acceleration, that acceleration is given as g. Remember that this g is written as, small g is written as capital G into mass of the earth divided by the radius of the earth whole square. Okay, that means this acceleration of the falling body does not depend on the mass of the body. It depends only on the mass of the earth and the radius of the earth, and of course the universal gravitational constant. That's why if we take two bodies of different masses and let them drop from same height, they will fall, or from any height actually, they will fall with same acceleration, and if they are falling from the same height, they will take the same time to reach the surface of the earth. Okay, it's a different case that they actually don't, because we do these experiments on the environment because of some air resistances are there and so on. If we do these experiments absolutely in vacuum, then you will see that they will take the same time if they are dropped from the same height, and of course they are moving with the same acceleration, does not depend on the mass of the body. So if a stone and a feather is dropped from a height or a building, they should take the same time to reach the ground. Remember that. Okay, so that's how you calculate the value of the small g, which is the acceleration due to gravity. Alright, that means the weight of a body is given as F equals to m into g. Okay, that's how you write the weight of a body. Remember that the SI unit of weight of a body is either Newton, or you write it kg weight in such a way, either Newton or kg weight. This is the way to write the SI unit of a weight of the body, of the weight of a body, not just kg or not just gram. Remember that kg or gram are the units of the masses in SI and CGS respectively. Right? Okay, so that's all in today's class. We will see you in the next class. We'll be talking about gravitation in the same class also. So see you in the next class. Till then, take care. Bye.